So the recording has begun. Good afternoon once again, everyone. Now, to recap what we would have covered last week. Last week, I would have given you two tasks to start for your SBA. I'm not going to go into detail. I already explained it in the recording. The recording is in the classroom. So watch that if you want for detailed explanation if you missed last week's class. Basically, I would have said that the first part of your SBA, if we go to the programming part of your SBA, you notice there is a problem solving section. This section, you basically have to create an algorithm. That's one. Two, you have to create a trace table. Three, create a problem statement. And then four, create a program, either using Pascal or VBA. So the two tasks I would have given you is one, to start your problem statement. I would have sent this document here already, whereby this is the structure. There's different methods of creating a problem statement. This is just one structure, one layout I would normally use. First paragraph, create a general introduction, mention what is the issue, what are the causes, and what are the effects of that said issue. Then the second paragraph, indicate what is your solution, how are you going to solve that problem, describe how the solution is going to work in terms of IPO, indicate what are the benefits of that solution, and then conclude. So that is your first task, to create a problem statement. Any questions in this here?
No, sir.
All right, moving on. Your next task was to create a IPO chart. We already practiced this. You should know the purpose of an IPO chart by now. It is simply a 3-column table, and you're documenting what is the input, processing, and output from this explanation here, from this description here. So that should be straightforward. You need the IPO chart as soon as possible. Nobody sent it to me since last week's class, because you need to start also working on your algorithm next. So the longer you take to start working on that IPO chart, the longer you'll be taking with your algorithm also. So please start working on that IPO chart after today's class. So that's your second task you were given. So it's IPO charts, and then we move on to algorithm. Those are your two tasks you were given so far. So what we're currently looking at in terms of content is how to create that algorithm now. More specifically, we're focusing on how to create a pseudocode. And I would have said that the difference between an algorithm and a pseudocode is that the algorithm is a bit more descriptive, whereas the pseudocode has more of a structure in that it uses keywords like input, read, and so on. This is the general layout as to how you will create a pseudocode. Your pseudocode always starts with a title. So you have the word pseudocode, colon, and then you create a title. You could put the keyword start or begin here as optional, but the title is usually an indication of the start of the algorithm. As the purpose of the title, to indicate the start. But if you want to put the keyword start and begin at this point here, no problem. After you create a title, you create a section of your algorithm called the variable declaration. We would have learned in chapter 9.2 Give me a second, let me find the document. We would have learned in chapter 9.2 about variables and constants. And I would have said that your variable and constants is basically what you use to store input. Whatever the person has to type into a computer, whatever the person has to enter so that you can process, has to be stored into a variable. We would have learned the difference between a variable and a constant. So, at this stage of your pseudocode, all variables must be declared. Basically, you must indicate what variables you will use in your algorithm. You must indicate what variables you will use in your algorithm. If you do not indicate that variable, then the algorithm or the pseudocode will not work. So it must be declared. So for example, if I take out number 3, which in that was a variable called number 3, and I say at step 3, input, and store that value into the variable number 3, that variable does not exist. So the algorithm, the program, it will crash. It will stop working simply because it was not declared. Are we following so far?
Yes, sir.
Yes, sir.
Any questions from anybody? Anything you want to clarify? All right. Are you guys hearing me properly? Any distortion? Or the sound is clear?
It's clear, sir.
All right, good. I'm asking because my computer is running a bit high right now. Chrome is overworking on my computer. I'm not sure why. And it's going to cause it to overheat. Let me see if I... give me a second. Let me see if I drop maximum process state 90%. What's at 90%? Alright, let me drop it to 85. Alright. Yeah, I'm not sure why. And then that. This is the only thing running. All right, let's continue. So, yes, all variables must be declared. Anytime you need to store data, you must create a variable to store that data. And how you create that variable or how you declare that variable is simply by following this method here in red. You state the name of the variable, equal sign, and then the variable type or the data type. We would have learned about various data types that we have: integer, real, character, and so on. So just like what you did in spreadsheet, whenever you are storing data in a cell, in a field, spreadsheet and database, you use the most appropriate data type. Whenever you wanted to store a date, you use the date time data type. Similarly, if you want to store decimal base numbers, the most appropriate data type is going to be real. If you want to store a word, the most appropriate data type is going to be string. So that's how we declare a variable. Now, a summarization method for declaration is the following that is highlighted in red here, that if multiple variables have the same data type, you can put it into the same line. It's not mandatory. If you do not want to, you can either write it out separate, as you see highlighted here. You can write it separate, or you can write it as one. Either one can work, does not matter. Both are correct. Now, after you would have declared a variable, the next stage is variable initialization. At this stage here, you give a variable a starting value. You give a variable a starting value. So this is how we create our constants. Because remember, constant is a type of variable where the value does not change. The constant is going to keep that one constant value. So at this stage here, we set that variable with that one constant value. For example, if you declare a variable called vat, and we say it's a real, then we can say vat is equal to 0.14. So the format is going to be variable name followed by value to be stored. The variable name followed by the value to be stored. So, for example, the variable vat equal 0.14. It's going to store that value of 0.14. Another example, if we have a variable called phrase equals string, because we're storing a phrase into that variable called phrase, then we would initialize it by saying phrase equal, but in this case, because it's a word, we will put it in quotation mark. Hello, how are you? Close quotation mark. So in this case here, whenever we use the constant or variable called phrase, this will appear. This phrase will appear. Hello, how are you? So a variable name followed by the value to be stored, that is how you initialize a variable. That is how you create a constant. Are we following? Clear so far?
Yes, sir.
Any questions from anybody? Anything you want to clarify so far about the layout?
You could use like an example from the SBA we gotta do for the variable initialization.
These are already examples. The exact thing you'll be doing, you're gonna figure out what name you want to basically create that variable as. For example, well, let me give you an example. First name, first underscore name equal string. But not all variables you would initialize. That's why I put optional at the end here, because you initialize a variable by giving it a starting value. You want that variable to have a starting value, or you want that variable to have that one value throughout the program. And in this case here, first name, this is a variable. Remember, variable changes throughout the program. So it's going to keep accepting different first name. So, for example, you may accept 10 first name into the program. That does not mean you have to create 10 first name variable. Variables are just there for temporarily storing the data. So you only create one variable for that data. And every time it needs to store that type of data, first name, is going to keep replacing the old first name with the new first name. So once again, we create a variable. Whatever variable we create is going to be reused throughout the program. So we don't have to create different variables when we're accepting different of the same data. This one here, this example here, needed 3 different numbers. It needed 3 different variables because we were accepting 3 different numbers at the same time. That is why we created 3 different variables for the 3 different numbers. We were accepting the 3 numbers at the same time. So we needed to store them at the same time. But the first name and last name, you're going to only be accepting one first name and last name at a time. Not everybody first name. Otherwise, then you would have had to create 10, 20, 30 variables to accept the different first name. So that's just something to keep in mind. Any other questions? No other questions? All right. Now, after initializing, that is when your algorithm is going to truly start. That is where you are going to actually have the steps that you're going to be taking to go from problem to solution. So using the example of adding 3 numbers, we're going to review back this pseudocode here. Step 1, we're using the keyword input. And once again, that simply means that the person is typing something on the keyboard. Now, when that person types on the keyboard, where is that data going to be stored? Into the variable called number 1. So that's why we created or declared it here. Step 2, we input again, or we could have said, what's another keyword for input? What is another keyword that we can use instead of input?
Read.
Read, very good. We could say read and store it into the variable called number 2. But point to note, if you're going to use input throughout the algorithm, the pseudocode. Don't switch between it. Switch between the input and read. Once again, we could summarize it if they are the same data type. Only if they are the same data type. Step 4, we have our process. We're adding 3 numbers. We take number 1, add it to number 2, then add it to number 3, and we store it into that variable called results. That is why, once again, we created declared a variable called result. If we did not, we would not be able to use this here. We would not be able to carry out step number 4. And the program, once again, will crash. Step 5, we output, or we simply put on the screen whatever is stored in the variable called results. So we're just looking at the basics of these keywords. Input, meaning that the person is typing, which it could be any form of input. And then we have output, which can have all the different forms of output, but we're only focusing on the output appearing on the screen. We're seeing the result on the screen. So output or put on the screen, whatever is inside of this variable called result. Any questions from anybody? And that's basically the layout. And then we have the keyword here, end, indicates the end of the pseudocode. That there is the basic layout of a pseudocode. So pseudocode has 1, 2, 3, 4, 5 main parts. A pseudocode has 5 main parts. 1, the title. 2, the declaration. 3, the initialization. 4, the body. And 5, the keyword end. The body would indicate input, output, body indicated input, output, and processing. Any questions from anybody?
No, sir.
All right, give me 1 minute to try to come up with an activity for you guys, because I want you to practice creating a pseudocode now using those same 5 parts. I'm just going to give you a simple pseudocode to create.
You sending this document to the WhatsApp group, right?
Yeah, after the class I'll send it. Alright, I think this might work. Let me save. Alright, so that is your task. So create a pseudocode to calculate the discount for an item. Create a pseudocode to calculate the discount for an item. Discount equal 5%. So you're calculating 5%. Ensure this is the task here. Ensure you have the 5 parts. You have your title, you have your declaration section, you have your initialization, you have your body, and you have your end, your 5 parts. What you can do also, if you want, is to create the IPO charts so that you can know what you have to input, process, and output, so that can make it easier to create the body. You may begin. Any questions from anybody? When you're finished, you can send the picture in the group. If you have any questions, you can let me know. Anything you want to clarify? I'll be back in a few minutes. I am back. If you have any questions, if you need any help, you can let me know. Are you guys getting through?
Yes, sir.
The same example I have there, it's basically the same thing you'll be doing. You just gotta follow the pattern of input, the pattern of how you do calculation, the pattern of how you output. You just following the pattern, but does that you have to now replace it with your variable, your calculation, your instructions, basically.
So like when we doing it, right? We gotta put input and then a value and then name of the variable for step one.
Well, not the value parts, but same pattern of input and where you store, which is the variable. Understand?
No?
So remember when you use the keyword input, you're indicating that the person typing something. So like in this case, the person typing in a price. So now, when the person type in the price, right after the keyword input, you have to indicate where are you going to store that value of that price. You should have already created a variable to store that value of price. So the structure is simply going to be input, and then whatever variable now is going to store that value.
Okay, answer now.
Yeah. I'm giving you guys 5 more minutes. All right, Oceana, your IPO chart is correct so far. You have the title, calculate item discount, good. Declaration, item cost, you put it as a real, discount value, real, discount, real, good. The variable initialization, the discount value, you initialize it to 5%, very good. I'm glad you remembered what I said about percentage. Then you start step 1, input, you store it into item costs. Then step 2, item costs multiplied by discount value, you store it in discount, and then you output discount and you end. Very good. Everything there is correct, Oceana.
Thank you, sir.
Lena, Erica, Nathan, Stephanie. Well, other than Stephanie, do you guys want more time or?
Yes, sir.
Alright, like how much more time?
2 to 3 minutes.
Alright, we can work with that. Alright, Stephanie, you have a title, discount for item, good. Start, declaration, original cost, real, discount percentage, real, result, real, good, original cost, discount percentage.
Oh, it switched. It was switched.
Hit switch.
The cost was supposed to be 500 and it's supposed to switch to 0.05 to discount percent.
Alright, fix it. Let me see what we're talking about. Alright, original cost. Alright. Very good attempt, Stephanie. But let's look at what we need to improve. So, firstly, you have your title. That's correct. So, let's go there. Discount for an item. Start. Then you have a variable declaration. Now, original cost equal real, discount percentage real, and then the result real. Good. So all of that is correct so far. Now, this initialization stage, we only initialize a variable if we wanted to have that starting value, or if we wanted to keep that value. So two reasons why we initialize. If we wanted to have a starting value, and if we wanted to keep that value. So in this case here, original cost, will the cost be 500 all the time?
No.
No. So you see where we're heading with this here? Do you think this is still needed?
No, sir.
No, this here is not needed. So you do not need to initialize the cost with 500. That is going to be step number 1, where the person is going to type in the 500 and it's going to get stored in the original cost. So you don't need to store the 500. the person at step number 1 will type it in and it gets stored into 500. So you can think of it that way. When storing value, it's either you are going to store the value before the program starts. That's the initialization. You're already storing that value before the program starts. Or you put whoever is working the program to type in the value. And in this case, the cost for the item, you have to let the person type in the cost because it can be different costs. So this original cost equal 500 is not needed. The discount percent equals 0.05 is correct. So the only thing wrong so far is this initializing 500. Everything is good so far. So start, step 1, you input, the person puts in and it's stored into original cost. Step 2, do you think we still need step 2?
Aren't we supposed to know what the discount percent?
But didn't you already initialize it here?
That's a part of the start end thing? Or different?
Repeat what you said.
The part with like after start, right? You aren't supposed to like put the different stuff in details, like everything.
Yeah, but remember the this step 2 here is not needed in this case here. It can work in other examples. It's not like technically wrong, but in this case it's not needed. Why? Because we already input the 5%. It's already input here. The initialization is technically like an input because you, as the creator of the program, you would have already input this 0.05 into this variable called discount percent. So you don't need to indicate that step here. It was already done. Think you follow?
Yes, sir.
But the step 2, like I said, is not technically wrong because say for example, you did not initialize the percentage, and this is for everybody. Say in this case, we did not initialize this 5% discount. Maybe there's different percentages of discounts. So this step 2 can work in that case, whereby step 1, the person puts in the original cost, the price of the item, and step 2, the person types in the percentage of the item. Maybe a pencil has a 1% discount, and maybe a ruler has 2% discount. Maybe a book has a 5% discount. So that's where this step 2 can come into play, whereby you allow the person now to type in what percentage you're calculated for that item. That can work in that scenario. But in this scenario here, we're using a fixed 5% discount. So it's always going to be this 5%. So we do not need to indicate that the person needs to put it in. So step number 2 is not necessary. Step 3, you take the discount percentage, multiply it by the cost, and store it into result, and then you output result, and then you end. Very good. So there's only those 2 things are incorrect. Any questions, Stephanie?
So for the variable initialization part, right? We only initializing the variable that will remain the same.
Yes. We're only creating constants at this stage here. So once a variable is going to keep a value, that's what you're doing here.
Okay, thank you.
Or if it's going to have a starting value. So like for instance, this same, like for example, this is for everyone also. You can take note of this also. This same discount underscore percentage, what she did here, with everything that she has, she initialized it with 0.05. So that means it is starting off with 0.05. But at step number 2 now, if the person types in a value, it is going to replace that 0.05 with whatever value the person types in. So in that case, it's an example of the variable having a starting value. So there's two things that you use the initialization once again for. One, to give it a starting value, and two, to give it a fixed value. So if, for instance, you take out step number 2, then it's going to have a fixed value because you'll never replace it. But currently how we have step number 2, it's just an example of giving it a starting value and then you replace it by something else. Any questions from anybody? All right, no questions. Let's move on to the next example. All right, I'm Lena. You have your title, calculate item discount, variable declaration, original cost. There is no equal sign here. Ensure you make use of the equal sign, or even a colon could work. Equal sign or colon. Real, discount percentage, same thing. Result, real. Initialization. Discount value equal decimal 0.05. We don't need the word decimal. Just equal 0.05. Initialization is just the variable name equal to the value that you want stored inside of it. That's all you need to put after the equal sign. Clear?
Yes, sir.
Start step 1. You have the keyword input indicating, so everything is good so far. You have the keyword input indicating the person is going to type something, enter the original price, but you have to indicate where this input is going to be stored now. So that's where, if you go back to these examples here, we have input and then a variable name that you would have declared. This is Stephanie's example. Input and the variable called original cost, which would have been declared at the top here as a real to store the cost of the item. So you're basically saying type in a value and store it into the variable called original cost. Clear?
Yes, sir.
Good. So that's how you carry out inputs. Step 2, discount equals item cost. So in your case, it should have been, and how you end up with item cost and you have original cost to the top here.
Yes, with the original cost.
Good, very good. Glad you saw that. So you can't, but just for everyone once again, you can't switch names like this here. Otherwise, it's a totally different variable. So you have to be careful with that. Even words that have similar meaning, it might look similar, it's not going to work. It has to be exact. So original cost multiplied by discount value, which is your 5%. Store it into discount. And then output. Can you tell me what's wrong with step number 3?
Supposed to be output discount.
Very good. It's supposed to be output discount. If you notice, you did not use this variable called result. Yeah, you created it, but in the calculation, you did not use it. So technically, it has nothing inside. So if you output result, it's going to work because yes, you declared it, but the output is going to be 0 because nothing is inside of it. So as you said, it's supposed to be output discount because discount is actually storing that value, and then you end. Good, very good attempt so far. Seems you have a relatively good understanding of it. Any questions? No questions on it? All right, Nathan's example. So Nathan has a title, discount for item, declaration, product cost equal real, discount cost equal real, discount equal real. Good so far. Initialization, the discount value. Nathan, you notice anything?
Yes, sir. Just noticing. It's supposed to be discount cost.
Discount cost. All right, good. Very good. So discount cost equal 0.05. Good. Then we start, we input, and we store it into product cost. Then step one. Step two, discount. We take product cost, multiplied by discount value, which should have been discount cost, stored into discount. Then step 3, we output discount. Very good. This here is correct. So other than the mix up with the name and the step number here. Very good. Very good attempt. And last but not least, Erica, the pseudocode 1. Discount, starts, declaration, cost item equal real, discount value equal real, result equal real. Variable initialization, discount value equals 5%. Starts. Remember to number your steps, Erica. Step 1, step.
Okay, sir.
Good. So we input and we store it into cost item. Okay, so I notice you have input discount value. So you heard the explanation I gave Stephanie, right?
Yeah.
So you know why this here is wrong. So discount value, your 5% is going to be multiplied by this cost item, stored into results, and then you output discounts. Anything wrong there?
Is it supposed to be discount underscore value?
No. If you're outputting the how much discount the item got, and based on your calculation that you have here, what variable do you need to output to get that discount?
0.05?
No. Alright, let's zoom into it a bit. So, you have 3 variables, right? You have your cost item, which is going to be the price of the item. You have your discount value, which is the discount percentage. And then you have your results variable. Here you have your discount value that's stored in the percentage. So that there. Now, step 1, you're telling the person to put in the price. We ignore step 2 because that's not needed. Step 3, we're calculating the discount value, which is this 5%, multiplied by the cost item the person would have typed in, and you're storing it into the variable called results, which you would have created at the top here. So, what should your output be?
Cost underscore item?
No. What are you storing your calculation into? When you multiply this 500,
Result?
huh?
Result.
Results. You're not seeing it here? You're seeing discount value, which is the 5%, multiplied by the cost item, gets stored into the variable called results. So this is your discount. This is how much discount the item is getting. It is in this variable called results. So you cannot say output discount, because discount, first of all, is not even a variable that you would have declared. Following?
Yeah.
So you never declared this variable called discount. So this program would actually crash at this end here. It's not going to work. That variable does not exist. So it's supposed to be output result, because you store the calculation into this variable here. Clear?
Yep.
Any other questions? Any questions on it?
No.
All right. Good. So overall, you guys gave a very good attempt at creating the pseudocode. Very good to all of you. But you can use, even though some of you were like 80%, 90% correct, you can still have a look at Save Oceana Zone. Have a look at hers. Hers is basically 100% correct. So you can use it as a reference. Remember, I'm not saying that yours is completely wrong, but up to a certain percentage. Good. Now it's 3:10. We have 20 minutes remaining. So let's continue with our chapter 9.3. Now, so far in this chapter, what we would have covered is basically what we just did, that activity. We would have looked at how to create a basic pseudocode, how to create our title, the input, the output, the processing, and so on. And we would have learned about what is sequential statements. Sequential statements is not anything that you create, basically, technically. It's just something that naturally happens, in that the statements are sequential in nature. They're executed one after each other. So that's why we call them sequential. So those same examples that you guys would have created, those are examples of sequential statements. You have step 1, it starts with step 1. You have step 2, it goes to step 2. You have step 3, it goes to step 3. It's sequential. It goes in order, one after each other. So that's what's meant by sequential statement. One statement getting executed after the other, in a logical order. So sequential statements are what we create naturally all the time. But not all pseudocodes are sequential, because some cases you do skip certain steps and you might reuse a step that was already used. So that is going to be a conditional branching or conditional statements. So we're going to be learning how to add conditional statements to our pseudocode now. So firstly, what is a conditional statement? Well, conditional statement or branching is used when there is a choice between two options. So it's kind of like if you're walking up a road and the road has a left and a right, and you have to choose now which side you are going to go. So the condition will basically determine what path you are going to take. So for example, KFC is on this side, and you feel like eating KFC, so you turn right. You go to this path here. But one day, you're on the same path, you're running the program once again, but you feel like eating pizza. So that's the condition now, you feel like eating pizza. So you go left. That's in a nutshell what is conditional branching. You take different paths in your program. So from a program perspective, you might go step 1, step 2, step 3, and you either do step 4, step 5, or you do step 6 and 7, and then you continue back with 8. I almost said 9. So you start off at step 1, you go to step 2, you go to step 3, but here you reach a branch off. Here you reach that fork in the road, and you have a decision. So you're coming along this way, step 1, step 2, step 3, and you either go left or right. Left is going to be you carry out step 4 and 5, and then you go to step 8, or you carry out step 6 and 7, and then you go to step 8. As in a nutshell, what conditional branching will allow you to do. Take different parts in the program, basically. So, 2 types of conditional statement or branching. We have if-then and if-then-else. Those are our 2 main types of conditional statements. The if-then statement and the if-then-else statement. We're going to be looking at the first one, the if-then statements. Now, what I want you to remember, to take note of, the then keyword. These are keywords also. Then is equivalent to the word true. Please always remember this here. Then is equivalent to the word true, and else is equivalent to the word false. Or you can simply say one is left and one is right hand. Going back to the same analogy of walking the path on a road, one side is left, one side is right. Basically, this side might be true, and this side here might be false. So, or it could be the other way around. But just know that one side is always true, and the other side is going to be the false side. Whichever side it is, it's just representing different parts. So whenever you see the keyword then, it's if the condition is true, because remember we're asking for a condition. We have a question basically. Whenever you hear condition, think of question. Think of it that way. Condition, question. Else is going to be false. So for example, you're going up the path once again. Do I feel like eating pizza? Yes, that's true. So we take the pizza side. I don't feel like eating KFC, so that's going to be false. So that's why I won't go the KFC side. So it's as simple as that. So let's go into a bit more detail now. If-then statements. The if-then statement suggests that one or more statements will only be considered based on a condition or the answer to a question. In a nutshell, it's the same as I would have explained here. One or more statements will only be considered based on a condition. Once again, one or more statements will be considered based on the condition or the answer to this question that we have here. So, is it true? Is the answer to the question true? Maybe we go on this side. Is it false? We go on this side here. So depending on the answer to the condition, we take different paths. Different statements will be carried out. So the keyword if is going to contain the condition. And in most cases, the conditions uses the operators, the more than operator, the less than operator, the more than equal to operator, the less than equal to operator, and so on. So the question is basically a comparison question. Is 4 greater than 8? Is the current year equal to 2023? Is the person's age equal to 24? So those are how the questions are going to be structured. Those are how the conditions are going to be structured. Is the person's age greater than 10? Is the person's grade less than or equal to 60%? Those are examples of conditions. Now, when we're checking for the condition, we are always checking to see if the condition is true. Always. That's the first priority. Checking to see if the condition is true. So if we're checking, is age greater than 10? We're checking to see if it is true. Is the age greater than 10? You can ask it in a question format. Is the age greater than 10? And if the answer is yes, then yes is basically saying true. And if the answer is no, then that's basically false. So the if is always the condition. You're asking simply a question. Conditions are simply questions. Is something greater than? Is something less than? Equal to? More than equal to? Less than equal to? Those are the conditions we are looking for. Those are the questions we are asking. And we're always, every question has a true and a false answer to it. It's either the question is true or the question is false. So that's how we end up with this then and else. Because all questions is either true or false. We don't look at middle ground. So it's either the person age greater than or it's not greater than. So, and we're always checking to see if that condition is true. We're always checking. So that's why this if then, it is only checking for the truth. It's only checking, it's only considering the true. It is not considering if the answer is false. We'll look at a bit later why it is not considering if it is false. So the then keyword, after this keyword then, it's going to have one or more statements under this then keyword. It's like if it reaches this part for true, it's going to carry out these statements that are in that section basically. And then you have the keyword end if to indicate the end of that if statement. So just like our pseudocode has the keyword end to indicate the end of the pseudocode, end if is to indicate the end of the if statements, the if conditional statements. So, any questions so far?
No, sir.
All right. Even if it's confusing now, when we practice it, you'll get a better understanding. So sometimes the keyword end if is used to indicate the end of the if then statement, as I already said. any statement below the end if in the pseudocode is therefore part of the general pseudocode and not specific to the if-then statement. So what I mean by that is simply that imagine your pseudocode. This is your pseudocode. This block here is a pseudocode. You have step 1 and whatever instruction there. You have step 2 and whatever instruction there. Then at step 3, you got an if. And then, so here is going to be your question or your condition. Step 4 is going to be then, and then your other statements. So basically we can summarize it like this way. This is going to be step 1 inside of this if, and then step 2 inside of this if, and then step 3 inside of this if. And then here, let me change the color. So basically this here is like a whole different section. And then here you have end if. So the end of that if statement. And then we continue out here with, technically this should be step 5, step 6, step 7, because we always go in a logical manner. We always number our steps in a logical manner. So this is supposed to be step 5, step 6, step 7, and then we have step 8 out here. So how the program is going to work is basically, where's my cursor? Yeah, we start off with step 1, step 2, step 3, step 4. We go on to step 5, step 6, step 7, and then we come out back and reach to step 8. So if the condition was basically false, we would have actually skipped all of this here and jumped from step 4 to step 8. Because remember, this is only working if it is true. So I'm just giving you like a general layout of how the program is going to work. You start off step 1, 2, and 3. Step 3, you enter the condition of the question. Step 4 is if the condition is true. If the answer is true, we would have followed the green line and turn in, run step 5, 6, and 7. When we see the end if, we come out back at step 8. But if it was false, then we would have jumped from step 4 to step 8, ignoring these true statements. That's a general idea as to how the if works. When you practice it, we're going to see more about it. So, all right, let me jump straight to the example. So, example 7, the example is to print the sum of 3 numbers if their total is greater than 50. Notice the question, notice the condition, if the total is greater than 50. So, the same example of adding 3 numbers, we have a title, pseudocode 7, add 3 numbers. We have step 1, where we read the 3 numbers. So say for example 10, 10, 10. Step 2, this is going to be 10 plus 10 plus 10, and that addition there gets stored into total is going to be 30. Step 3, this is an example as to how you write the if statement, if then statement. We say if, and then the variable. So in this case, we're checking to see if this variable total is greater than 50. So it doesn't have to be a variable. It could have been maybe if 50 is greater than total. It could have been that way also. But in this case, now we're checking to see if the variable total is greater than 50. So what we got to ask ourselves, is it true or false? What's the answer? Is total greater than 50? True or false?
False.
Correct. False is correct. Because 30 is not greater than 50. So the answer is going to be false. So, would we carry out step number 4?
No.
No. So what that means is that step number 4 is going to be ignored. Step number 4 is going to be ignored. Why? Because as I said, then is true. You only carry out the statements that are under this then keyword if the condition is true. But currently the condition is false. So that means we do not carry out this line. We do not carry out the action of this line here. And then we go to step number 5, end if, and then we end our program. Are you guys clear in this so far? You guys understand what is happening here?
Yes, sir.
The rest of you following or no?
Yes, sir.
All right, let me give you another example. And then we are going to wrap up. So, same example. We're reading 3 numbers. This time is going to be 20, 20, 20. We need to add those 3 numbers together. Remember I told you guys whenever you are reading a pseudocode, an algorithm, a flowchart, always write down the answers like we see I'm doing. That way it helps you to follow it better, to trace it better. So 20 plus 20 plus 20 is going to be 60. Now, is total greater than 50? True or false?
True.
True. Because 60 is greater than 50. So the answer is going to be true. What is our next step? Is it step 4, 5, or 6?
4.
Step 4. Simply because the condition is true. So we must carry out the actions that are under this then keyword. So in this case, we will now print what is in this variable called total. So 60 will appear on the screen. Then we end the if statement and we end the overall pseudocode. Are you guys clear in how the if statement works?
Yes, sir.
The rest of you, Amlina, Erica, Nathan, Stephanie.
Yes, sir.
Yes, sir.
Yes, sir.
All right. All right. So, well, to summarize what we covered today, I basically showed you how to create a pseudocode, a problem statement, how to create an IPO chart. We looked at the 5 basic parts of a pseudocode, and then we just looked at how to incorporate another statement into our pseudocode called the if-then statement. Next week, we're gonna look at more examples of it and then continue from there. Any questions before we close?
No, sir.
All right. If no questions on today's class, that will be the end. Enjoy the rest of your day.
Bye, sir.
Goodbye.